question, we're asking this question to find the triple integral of x squared plus y squared plus z squared dv, where R is the region inside the sphere, x squared plus y squared plus z squared is 1, and above the cone, z is equal root x squared plus y squared. Now, first of all, let's sketch this region. Let's give a rough sketch. It's a bit difficult to sketch it in 3D. This is the sphere of radius 1. Let me change colors. This is the sphere of radius 1. And this is the cone z is equal root of x squared plus y squared. So really we're integrating inside the solid region, above the cone and inside the sphere. Now we could characterize this region in many ways, but since we have to integrate x squared plus y squared plus z squared, it is, I think, better to use spherical coordinates in that case. So let us solve this question, and let us recall that spherical coordinates, x is rho sine phi cos theta, y is rho sine phi sine theta, and z is rho cos phi. And of course, as we know, that rho squared is x squared plus y squared plus z squared. Okay, so first, it's clear then the function we're integrating is rho squared. Great. What is left here is to describe R in terms of spherical coordinates. So of course, R is inside the sphere, so we could say that rho is less than 1. Is inside the unit sphere, so rho is less or equal to 1. Now, how could we describe the cone? So let us draw the cone here in yellow. This is the cone. Z is equal to square root of x squared plus y squared. Now notice that rho, z is rho cos phi. And root x squared plus y squared, what is the x squared plus y squared? It's not very hard to see that root x squared plus y squared is rho sine squared phi. Just expand that. We can do this here. Well, let's write this. X squared plus y squared is rho squared sine squared phi. I'll just take a cos squared theta plus sine squared theta, which is just rho squared sine squared phi. Now the square root of x squared plus y squared is the square root of rho squared sine squared phi. Now we know that rho is positive. Technically rho is defined to be the square root of x squared plus y squared plus z squared. And we know that sine phi is positive, since in spherical coordinates, phi belongs to the interval 0 pi. So phi is non-negative. Hence, z is equal to square root of x squared plus y squared implies that rho cos phi is equal to rho sine phi, which implies that cos phi is equal to sine phi. Now, if phi is in 0 and pi, between 0 and pi, and cos phi is equal to sine phi, then phi must be equal to pi over 4. So really, above the cone mean that this phi is ranges from 0 to pi over 4. So phi must range from 0 to pi over 4. And theta, of course, ranges from 0 to 2 pi, because, when you project this region here, or, when you look at this region, you have a full turn on the xy plane. So theta ranges from 0 to 2 pi, and r and rho ranges from 0 to 1. Now x squared plus y squared plus z squared is rho squared. Now before we move on to d rho, d phi, d theta, we do not need to forget the Jacobian in this case, which is rho squared sine phi. Great, now this is easy to integrate. I'm integrating over a cube, in the rho phi theta plane. This is not very hard to integrate. So let us do the integration very quickly. And it's a product of functions of rho and a function of phi and a function of theta, which is 1. So the integral is a product of these three integrals. Rho squared times rho squared is rho to the 4d rho. So this is 2 pi times the antiderivative of sine phi is minus cos phi from pi over 4 to 0 times rho 5 over 5 from 1 to 0. So we get 2 pi minus cos pi over 4 is minus root 2 over 2 plus 1 times 1 over 5. So this is 2 pi over 5 times 1 minus root 2 over 2.